Having read Darwin's Origin of the Species and being very interested in the origin of biodiversity, we were interested in finding out what is the process of speciation. How do different species arise? Darwin had set this up as a question, and he had suggested, actually in a letter to a friend of his, that the best place to look for this would be young adaptive radiations. And having looked at various different radiations, we decided that Darwin's finches were just perfect for this. And they were perfect for several reasons. One was that they were very young. They were a young adaptive radiation. They occurred in the Galapagos Islands on different islands, together and separately. Some islands had many species, some just a few. The islands are pristine, so any changes that we were likely to see would be the result of natural changes and not induced by any humans. And furthermore, the Galapagos occurs astride the equator, and that means that it's subject to the El Niño Southern Oscillation phenomenon, which also means that some years there's very dry and many birds die during these droughts, and then other years are extremely wet when both the vegetation and the finches multiply. So that seemed a perfect situation where we might see changes in the phenotypes of the birds and be able to measure them.
I would just add that in emphasizing what Rosemary said, Galapagos Islands, many of the islands are in almost untouched condition. Humans have done very little to leave an imprint on almost all of the islands. So we do study the natural occurrence of evolutionary and ecological phenomena in an environment that is simple enough that we can interpret what we are able to discover. Yes, my supervisor, my mentor was a man called Evelyn Hutchinson, who wrote a book entitled The Ecological Theatre and the Evolutionary Play. And that captures the notion of a link between these two processes in nature. The evolutionary play is almost by definition, a dynamic narrative story. The environment in which evolution takes place is equivalent to the theatre, and that also is dynamic. It shouldn't be thought of as fixed, but scenery is changed from one scene to another, from one act to another. And so the interplay of ecological dynamics and evolutionary dynamics is essential for us to be able to understand how biodiversity is generated and what are the forces that are promoting and subverting those processes. So that, I think, is a connection between ecology and evolution, and the study of evolution without a knowledge of ecology is almost a study in a vacuum.
I wouldn't really add anything more to that. I think that is exactly how I would answer it as well. Of course, we had many conclusions, but I think the main ones are that we've been able to measure changes in phenotypes in populations of birds as a result of changes of the environment. So that is one. The other very big one, I think, is that we have been able to show 3 different models of speciation. One, we have been able to document and measure the one that Charles Darwin suggested, which is now called the allopatric speciation model of speciation. But the other that Darwin didn't think of and didn't know, and that was the importance of introgression, that is gene flow from one species into another species. And that can work in 2 ways. It can merge 2 species together, and therefore species will become different on one island from the same species on the different islands. But the other, much more exciting one, we think, because we've been able to follow it from its inception through for 6 generations, and that is gene flow from one species into another in a new environment can set a population off into a new trajectory and form a completely new lineage which is acting as a new species.
I just add a couple of things by way of emphasis. One is that I think an important factor that emerges from the research is that evolution of long-lived animals, like birds, they can live for as long as 17 years, for example, can be studied and has been studied and is found to occur rapidly where the environmental circumstances determine that, and that it recurs. It's not just a singular event. Over 40 years, we studied 3 major evolutionary episodes, and the good advantage that we took from studying the birds on a small island is that we knew enough about the ecology to be able to interpret evolution when it occurs. So that the main message, I think, for other people is it is possible to study evolution in contemporary time of a magnitude and of a direction that is of significance to people who are interested in biodiversity. The significance, I think, of the connection between biodiversity research and conservation that emerges from ours is that they are essentially 2 sides of the same coin. In biodiversity research, we ask what produces new species. In conservation biology, we ask what reduces species. The 2 are clearly linked together because without knowing the one, that is, let's say, conservation biology, we are not able to answer the first question adequately. We might, for example, find ourselves studying organisms in an environment where, due to human manipulation, the environment is deteriorating, and so we're not studying the natural process. So I would say, I would stress the link between these 2, the fact that conservation biology and biodiversity research are intermingled or intertwined, interrelated very strongly, and it's not easy to be able to draw much conclusion about either the one or the other without knowing about the other one.
I think I'll add to that is that we have been able to show that both species and environments change. And I think what is so important for conservation is that if we are to have a sustainable environment, we must take both the change of the environment and the change of species into consideration.